Hello class, welcome to the first part of Earth's dimensions and navigations. Today we're going to be going over Earth's shape, lithosphere, hydrosphere, and atmosphere. Make sure you have access to your Earth Science reference tables. It can be found in the resources of the Google Classroom. Now, how do we study Earth? We create models which are representations of something that's too large or too small or too complex to study in the classroom. You guys have seen these such as maps, globes, or diagrams. What is the shape of the Earth? Earth's shape is an oblate sphere. Now, as we look at this picture, we would consider it a sphere, but in actuality, a sphere is just a three-dimensional round shape. But how do we know Earth is spherical? Our best evidence is photos from Earth from space. We also know it's spherical because when we look at stars, they appear to change positions, in the sky as an observer moves to the south. For instance, the North Star Polaris. When I'm at the equator, it's right at the horizon. As I move north from the equator to New Orleans, Louisiana, it rises about 30 degrees. And then when I get to the North Pole, it is at 90 degrees north. 90 degrees above the horizon. We're going to talk a little bit more about Polaris when we get to latitude and longitude. You can see Earth's curved shadow when the moon becomes eclipsed. So when the Earth comes between the sun and the moon, we can see the shape of the Earth being casted upon the moon. Now, as objects move away from an observer, it appears as if an object is slowly sinking because of the curvature of the Earth's surface. And this is when we talk about the boats that might be on the ocean. Let's say your friends set off on sail, and they're going out to sea. In the beginning, you only need to use a 50 times lens, and that's about 915. As the day progresses, they keep going farther and farther away, and you have to increase your magnification of your lens. About 3 hours later, they are far enough that you have to use their 100 times lens. And then another 4 hours pass by, and we're at 200 times lens, and you can see as if the boat is sinking, but it's not. It's just going around the curvature of the Earth. The term oblate means Earth's equatorial diameter is slightly wider than the Earth's polar diameter, slightly bulging at the equator and slightly flattened at the poles. This is a result of Earth's rotating on its axis. So here's our dimensions of the diameters. The polar diameter measures to be 12,714 kilometers. The equatorial diameter measures to be 12,757 kilometers. This is not a large difference when we're considering the size of the Earth. The evidence to show that the Earth is oblate. Objects weigh slightly more at the poles than at the equator, because as you get closer to the Earth's center, there's going to be a stronger pull of gravity. We also have measurements of space photos. Now, this is just exaggerated, but if you were at the pole, you'd weigh more because you are closer towards the center of the Earth than you would if you were on the equator. The weight difference at the poles versus the equator is very small. To the naked eye, photos of Earth look perfectly spherical. Now, where are the parts of the Earth? In this diagram here, we see the continental crust, lithosphere, oceanic crust, and then we see the lithosphere and upper mantle. The lithosphere is the solid part of Earth. It's what we stand on. We stand on the lithosphere. It consists of the crust, which is bedrock, continents, ocean floor, and also the ridge and mantle, which is right below the crust. The hydrosphere represents all the water on the Earth. This be with oceans, lakes, rivers, groundwater. And about 75% of Earth's surface is covered with water. Then we also have our atmosphere, layer of gases that surround Earth that are divided into 4 layers based upon the composition and temperature. Now, this is important because on page 14 of your Earth Science reference tables, okay, it goes over the layers of the atmosphere. Okay, you will need to use your reference tables to help you answer the checkpoints at the end of this lesson. Okay, we can see our atmosphere, which is located above the land before we get into outer space, between B and D. So information regarding the composition of the 3 spheres can also be found on ESRT page 1. Okay, the average chemical composition of Earth's crust, hydrosphere, and troposphere. Here we see the chart that's on page 1 of the Earth Science reference tables. Again, that's located in your resources tab on your page in the Google Classroom. If you have the opportunity, okay, it might be worthwhile to print it until we can actually get you a copy in the school. So the crust is our solid part of Earth. Remember, another name for the crust could be the lithosphere. Okay, it's broken down by element, and then it's by mass and by volume. Now, mass is the number of particles that it contains, while volume represents the amount of space it takes up. Our hydrosphere, which is liquid water, and our troposphere, which is the lowest level of Earth's atmosphere, which are the gases. Okay, we're going to talk about that in a little bit more detail shortly. So when you see the term abundant just means a large amount of. Now, I said we're going to talk about the atmosphere. Information regarding Earth's atmosphere can be found on page 14 of your Earth Science reference tables. There's a total of 16 pages in the reference tables. And this is what it looks like. Here we go, a nice little tour. Okay, what is this? What is the scale for kilometers or for miles? Okay, when we look here, okay, we see kilometers on the left-hand side and miles on the right-hand side. Both scales start at 0. Okay, so as we come up from 0 to 40, each one of these increments is 10 kilometers. So we can see it goes from 0, 10, 20, 30, 40. Okay, if we had all these measurements on there, okay, the graph would be pretty crowded. When we go to miles, miles is done in 5-mile increments. Okay, so we can see it goes from 0, 5, 10, 15, 20. So when we get to 40 kilometers, okay, it's close enough to be figured 25 miles. And then at the bottom here, we have where sea level is labeled. Okay, altitude is just the height above sea level. Okay, going towards outer space as we go up from sea level. Okay, and then you can see where we have this little diagram or stick figure drawn. Okay, this is where we live. We live near sea level. Okay, we're obviously not that tall. I think that guy's about 5 miles tall. Okay, and there are 4 layers to our atmosphere and we're classified by temperature changes. Our first scale here is temperature. Okay, and in the troposphere, temperature decreases. On an average, it's 15 degrees Celsius at the surface, and as we go up from the troposphere, it gets down to negative 55 degrees Celsius. So it gets colder. The next layer, we have our stratosphere. In the stratosphere, look at the temperatures. Okay, it's going from negative 55, and as we go up in altitude, it gets warmer to get to 0 degrees Celsius. So it gets warmer as we increase altitude. The next layer is the mesosphere. Okay, it starts where the stratosphere left off at 0 degrees Celsius, and then it gets colder all the way to negative 90 degrees Celsius in the mesosphere. Okay, then our last layer, which extends actually out to 600 kilometers. Okay, our chart only goes up to 160 kilometers. Okay, is the thermosphere. Okay, in this thermosphere, okay, it gets warm. Okay, it can actually get very warm because as you see here at 100 degrees Celsius, okay, we're roughly about 120 kilometers above the Earth's surface. Okay, our next chart to the right is our atmospheric pressure. And on the scale here, we can see 0 and 1. As I go up in my altitude, okay, the scale shifts to the left, okay, but it never really gets to 0. Pressure never decreases to 0, okay, as it goes up. But as altitude increases, pressure decreases. Our next chart on the far right is water vapor. Water vapor is just a concentration of water, okay, the mass of water, or how much water is in a given space, okay, almost like the volume. So water vapor forms clouds and weather. Almost all water vapor is found in our lowest layer of the atmosphere, which is our troposphere. So what is Earth's atmosphere composed of? Okay, the 4 layers of the atmosphere, again in review. Okay, we have our troposphere. It's the closest to the Earth and most important because it contains all the elements necessary for our lives. Okay, this is also where all weather occurs. We have the stratosphere. It contains the ozone layer, which absorbs UV light. Okay, our highest planes will fly up in this region. Okay, you guys will also be getting a video of Felix Baumgartner. Okay, he was a Red Bull skydiver, and he jumped from this layer. Okay, you guys get to watch as he jumps out of the capsule with his spacesuit. Okay, how fast he's going and the temperature changing. The mesosphere. Okay, shooting stars will burn up here. Okay, and then our last layer of the atmosphere is the thermosphere. Okay, this absorbs high energy radiation from the sun. Okay, that's why the temperatures up there are so high. Okay, and our satellites orbit there. Okay, between the spheres, okay, we have these things called interfaces or boundaries of the layers, and to when we put name to them, okay, we call them with pauses. So the tropopause is between the troposphere and the stratosphere. The stratopause is between the stratosphere and the mesosphere. The mesopause is between the mesosphere and the thermosphere. Okay. Now, on October 14th, 2012, Austrian skydiver Felix Baumgartner jumped from 39 kilometers above the Earth's surface. Which layer of the atmosphere did he jump from? Is this outer space? Use your Earth science reference tables on page 14 to answer this question. 2. Which layer of the atmosphere is most of the water vapor located? Make sure you use page 14 of your Earth science reference table to answer this question. 3. Name the layer closest to Earth's surface where temperature increases as you increase altitude. Again, use page 14 of your Earth science reference table to answer this question. 4. What happens to atmospheric pressure as you increase altitude? Use page 14 of your Earth science reference table to answer this question. And our last question. At what boundary is the coldest temperature found? Okay. Keyword there is which boundary. Okay. Make sure you use page 14 of your Earth science reference tables to answer that question.